We gain tremendous efficiencies by being able to utilize a centralized resource that's supported from the university, such as the high-performance computing cluster. We regularly need a lot of power and a lot of storage space because the types of data that we're generating are very large and therefore require significant space to hold on to them, and then also require significant space and computing capacity in order to crunch through them. We don't really have the expertise either on my brain tumor team or within the core that I help run within the Cancer Center to really know how to architect, design, build, and maintain these types of clusters. And so because the university has invested heavily in order to build and run and maintain the cluster, this gives us a huge advantage because then we can just use it. So, you know, the fact that it's a centralized resource really makes a big difference for us. Number one, because it's available, and number two, because when we're writing grants, which is what we do a lot of, it looks really, really good in grant review for the reviewers to be able to see that your university has prioritized something like this and is helping to augment the funding for it, so that the onus doesn't completely fall on the investigator. I suppose that I can't emphasize enough the importance of prioritization of making high-performance computing and storage a priority for the university and having that be an essential piece of its infrastructure and available for researchers, because it really has helped us tremendously, both from the Cancer Center, biostatistics and bioinformatics course side, but also within my own research studies in brain tumors.
Well, the research we do has to do with making theoretical models of the visual system and auditory system. And what that entails is a lot of computation. So high-performance computing, first of all, allows us to do a lot of computation in a short amount of time. And the simulations are large, so we have to, when you're trying to simulate something like the visual system, it's really processing a lot of visual patterns. And when we make theoretical models, essentially what we're trying to ask is, what's the optimal way to process those patterns so that you can make a prediction about, from the theory, about what the visual system organization should be, or the visual system computation should be. The high-performance computing allows us to basically do those experiments much faster. And we can utilize hundreds or thousands of cores on the GPU to do a lot of parallel computation. My students, for example, have been able to speed up the simulations which we were doing on our workstations something like 60 to 80 times. So it's a huge savings. And normally, like in some of our simulations, we would have had to wait 2 weeks to get an answer. So that really slows down the process of exploration. But when you get an answer in the same day or overnight, it's much more efficient.
Currently, we are using them to support clinical trials in the medical school. So it's mostly with clinical departments. These are phase 3 clinical trials, the ones that that ITS database people work on currently. So there is a lot of work to be done on the area of data management. So with ITS, the database group, they have been really invaluable in helping write proposals, because now data management is taken much more seriously. There are issues of clinical trials funded by the NIH, for instance. There are requirements of data sharing, and that is not a trivial thing. There are also, because there are human participants, there are issues of confidentiality, who has access to the data and so forth. And the ITS group is very, very well prepared to address all those issues.
Well, ITS has been very helpful in just getting us set up and getting us up to speed quickly. We had actually started to make our own server and compute cluster before. When we found out about the High Performance Computing Center, then that alleviated us from all the work and headaches you need to do to set up something like that. So it was a tremendous benefit. And we've also been able to work with them to install, for example, the latest drivers on GPUs and things like that, and get all that working very smoothly. So they take care of the technical side, and we take care of the research side, and it all works very well. To really get down to the hardware and understand how certain types of hardware excel at certain types of computations is really a technical expertise that requires a lot of different experience, and ITS, I think, is at the perfect position to really get a handle and insight into what works well for different applications.
ITS has helped, for instance, in the design of data entry forms, so that there is, so that the paper copies and what you see on the screen are similar, so that there are quality checks built in and so forth. And the time that is spent on those types of activities really help tremendously all along the trial, for monitoring purposes, for reporting purposes, certainly for data analysis purposes. When it comes to de-identifying the data, I wouldn't be able to do it. I haven't, I can tell the database people what are the items that cannot be shown. And it's not just the name and address and things like that that are obvious. There are some things, for instance, dates of follow-up visits that cannot be there. So how do you put that information in a database in a way that patients are not, the data is de-identified, but at the same time I get the data that I need? There is no way that I could do that. I go to the website for one of the databases. There is a website developed by ITS. I go there. I have the different files that are really ready to be downloaded. I can download them in Excel, move them to some statistical software, and the data is clean. Actually, for another clinical trial, we've done sort of informal audits for quality control, where we compare what's in the database against what's in the paper records, and the error rate is minuscule.
Their input has been critical to us being able to move forward with getting a compliant space within the high performance computing and the Case Western Reserve University Data Center in order for us to store data on patients where we have identifying information on them. And that is really critical for much of the research that goes on within the Cancer Center, and for my own research in brain tumors. Someone from ITS, Mike Worf, is directly involved with the bioinformatics core that I run for the Barrett's esophagus grant. And Mike is involved because of database needs that we have. So again, that fits right in with the clinical research informatics and the need to have identifying information, data housed and stored securely in a place that allows us to have a centralized place that's safe to put data on patient demographics, patient identifying information, survey data, images, pathology data, biospecimen data, and omics data.